Fluid flow processes, one of the most important processes that an engineer must understand because of its involvement in many different industries, such as water treatment, petrochemicals, and biotechnology. At the University of Massachusetts Amherst in the Chemical Engineering Department, after extensive training, students are given the opportunity to work with real fluids in their senior year. This apparatus provides many pieces of equipment one might encounter in the industry or lab environment, providing a microcosm for students to experiment or fail on. The apparatus starts at the reservoir where liquid is held. There are two pumps, one or both of which can connect to the two primary circuits present. Inside each circuit, there is a meter. The top circuit contains what is known as an orifice plate, which is used to measure the flow rate of a gas or fluid. The bottom circuit contains what is known as a Venturi meter, which is used to measure the flow rate of a gas or fluid. Both are used to measure the flow rate of a gas or fluid. Both circuits also contain a number of pressure gauges and valves, which can be controlled and read both manually and electronically.
After leaving the Venturi meter, the water flows around to the other side of the apparatus and enters the globe valve. Leaving the valve partially open will cause the water to divert its flow to fit into the smaller area. In the same way that a Venturi meter causes friction, so does the globe valve. This causes the water to lose energy, causing the pressure to lower in the pipe after going through the globe valve. The water then flows through a second valve we call the control valve. This is because the valve is controlled by the computer. Watch. As I move the valve from 100% to 50%, the valve moves. After going through the control valve, there are two options of where we can put this water next. The first is to flow through this pipe and bring the water all the way up to the top of the holding tank. The second is to flow the water into a smaller vessel, which is attached to a scale, which allows us to find the mass of the water flowing through. The flow of water in this apparatus is similar to all fluid flow and is governed by the laws of conservation of energy. You are probably a little familiar with it. Energy can never be created nor destroyed, only transferred. In our system, we add energy to the water using pumps. The energy is stored in the water in three different ways, the first of which is kinetic energy. This is because the water is moving and has mass. The second is gravitational potential energy. This is the energy associated with height. You are probably familiar with this, such as when you let go of a ball. The gravitational potential energy is transferred into kinetic energy. Believe it or not, this also affects water. The third form of energy is different from the ones you are used to and is related to pressure. It takes energy to pressurize a fluid, and a pressurized fluid can quickly transfer that energy to kinetic energy when depressurized. When a fluid is flowing, these three quantities, the kinetic, gravitational, and pressure energies, are mostly constant throughout a flowing liquid. Designing efficient fluid flow systems is an important aspect of chemical engineering. As a chemical engineering student, you will learn how to understand the challenges of fluid physics and chemistry using both math basis to calculate various quantities and reasoning to be able to use your intuition to understand how a chemical process works.